Your laptop disappears at an airport. Disk encryption was off, or the machine was asleep, or the attacker pulled a copy from a backup drive. In your home directory sits .ssh-add 2519, the private key that logs into production. If that file has no passphrase, the thief may not need your Linux password, your shell history, or your VPN notes. They already have the credential. If the key file is passphrase protected, the story changes. They stole an encrypted file, not an immediately usable login token. That is the whole point of an ssh-key passphrase. An ssh-key passphrase is a local secret used to encrypt your private key file at rest. It is not your account password on the remote server. It is not transmitted during SSH authentication. The remote host never checks it. The passphrase exists because private keys are powerful bearer-like credentials. Possession of the usable private key can be enough to authenticate. So OpenSSH lets you wrap that private key in encryption. When you use the key, your local SSH tools unlock it, then perform public key authentication. The server still only sees proof that you control the private key, matching a trusted public key in authorized keys, or in whatever key system your environment uses. Mechanically, modern OpenSSH private keys can be stored in an encrypted private key format. The passphrase feeds a key derivation step, then that derived material unlocks the private key. The exact algorithms have changed over time, but with current OpenSSH, you should think deliberately slow password-based protection around the file. When you run SSH or ssh-add, the unlock happens locally. After that, SSH authentication uses signatures. The server sends a challenge, your client or agent signs it, and the server verifies the signature with your public key. The passphrase is not part of the network protocol. It protects the file before use. It does not make a compromised live session safe by itself. Here is the basic workflow using a demo key, so we do not disturb your real one. First line, generate an ed 25519 key at .ssh-id demo. ssh-keygen will ask for a passphrase. Choose one you can type, but do not reuse a website password. Second line, change the passphrase on an existing key. This is useful if you created a key without one, or if the phrase is weak. Third line, start an ssh-agent for this shell and load its environment variables. Fourth line, add the private key to the agent. You type the passphrase once. Fifth line, list keys currently held by the agent, usually by fingerprint and key type. Let's work the stolen laptop case like an administrator. First, assume the private key may have been copied. A strong passphrase buys time, but it is not a reason to leave access unchanged forever. Second, identify where that public key was trusted. Servers, Git platforms, jump hosts, automation accounts, network gear. Third, remove or disable that public key everywhere. If you manage authorized keys with configuration management, push the removal rather than hand-editing one server at a time. Fourth, generate a new key pair on a clean machine with a passphrase. Fifth, deploy the new public key, test access and review auth logs for accepted public key logins around the loss window. The common mistake is treating a laptop key like it lives in a locked data center. Portable machines get lost, repaired, imaged, synced, and backed up. Empty passphrases there are a bad trade, unless another control clearly replaces them. Second mistake, typing the passphrase all day instead of using an agent. That trains people to choose weak phrases. Third, forwarding your agent everywhere. Agent forwarding can let a compromised remote machine ask your agent to sign while your connection is active. Use it only when you understand the path. Fourth, forgetting backups. If your home directory is backed up, your private keys are too. And finally, rotation means removing old public keys, not just creating new ones. In the foundations tier, we are building the mental model before hardening knobs. Password logins prove knowledge to a server. SSH keys prove possession of a private key. Passphrases protect that private key when it is stored as a file. Agents reduce the pain so the safe option is usable. Later, we will spend a full episode on hardware-backed keys, open SSH security key types such as ED25519SK and ECDSA-SK, when your version and hardware support them. Those can change the theft model because the private key material is not just a normal file. For today, understand the baseline: file key, passphrase, agent, rotation plan. 5-minute practice on your own machine or a disposable VM. Create the demo key shown on screen and give it a passphrase. Load it into your agent with ssh-add. If your desktop already runs an agent, that may be enough. If not, use the agent command from the earlier card first. Run ssh-add-l and look at the fingerprint. Now change the passphrase with ssh-keygen-p. And notice that the public key does not change. You changed the encryption around the private file, not the identity of the key pair. When done, remove both the demo private key and the demo public key. 3 beats to keep. 1. An SSH key passphrase encrypts the private key file at rest. It protects you when the file is copied from a laptop, backup, or home directory, but it is not sent to the server. 2. ssh-agent makes the right choice livable. Unlock once, then let the agent sign for your sessions. 3. If a private key may be stolen, rotate. Remove the old public key and issue a new key pair. Tomorrow we keep building the SSH foundation with another practical topic. New SSH episode daily on this channel, plus the daily ranked CVE brief for administrators, tracking what needs attention.